Hello. Continuing on, we have bacteria can grow at an exponential rate under certain circumstances. In a given experiment, there are 4 at the start, or they might also say initially in an exam style question. So there are 4 bacteria at the start or initially. Now, part 1. Find A if f of t is the number of bacteria after a given time t in minutes. So I'm looking for my capital A here, which is dot producted. So there could be a dot in between those, though when they're in letter form, there often isn't. So I'm looking for the value of capital A, the constant in front of my exponential type function. And I'm told in the introductory sentence that there are 4 bacteria initially or at the start. Well, what does that mean? It means at the start is when t is equal to 0. And I'm told that f of t, or f of 0, is equal to 4. So I'm told that when I start, I have 4 bacteria. So let's sub that in and see if we can use it to find A. So f of 0 is equal to 4 is equal to A dot e to the b multiplied by 0. Now e to the b multiplied by 0 is just a number to the power of 0, which is just 1. So I am left with A multiplied by 1 is equal to 4. Therefore, A is equal to 4. This is a very, very common first question in exam style questions of this type. Now, part 2. If the doubling time is 2 minutes, find the growth constant B. So B is our letter up here. And you'll notice that if I was doing this in an exam, I might be daunted by the fact that I had 2 unknowns in my equation and I wasn't given enough information to find them in part 1. But because I end up multiplying by 0, as you can see, I don't need to know B in order to find A, just to highlight that fact. But now I am looking for B. B is often called the growth constant, and in the back of our minds we should have that noted, though they should always tell you the letter that they are looking for directly instead of just using a name for it. But knowing that this is called the growth constant or sometimes the growth rate can be helpful in interpreting questions. So if the doubling time is 2 minutes, find the growth constant B. What does doubling time mean? It means exactly what it says. We are looking for the amount of time, it takes 2 minutes in this particular case for the amount of bacteria to double. So let's put that into practice. I know the number of bacteria at f of 0, at t is 0. So I'm looking for f of t is equal to twice f0. Or rather, I have f of 2, I should say. So if my doubling time is 2 minutes, then from 0 to 2 is 2 minutes. So when t is 2, I have doubled my amount of bacteria from the start. So let's sub into our formula. I now know that A is 4, so I get 4e to the b by 2 is equal to 2 on f of 0 is just 4. So I get 4e to the 2b is equal to 8. Get the exponential by itself. I get e to the 2b is equal to 2. I'm going to take the natural log of both sides. So again, I'm advising you always take the natural log of both sides in order to get exponentials down. So this power now comes down and out. And I end up with natural log of e, which I should recognize is just going to be 1. So I end up with 2b is equal to ln of 2. then I am going to divide both sides by 2. To get b by itself, and I end up with a kind of a funny looking b, but it's a perfectly valid answer. Ln of 2 all over 2. So that is my growth constant. Now the last part, when will there be 64 bacteria? So I'm looking for f of t is equal to 64. I'm going to break up my page again so I have a little bit more space to work. So I have part 3, and I'm looking for f of t is equal to 64. So t is equal to what? And I am going to sub in to my formula. I now know the full version of my formula. F of t is equal to a is 4, e to the b is ln of 2 all over 2 times t. And now I want to find when that is equal to 64. So 64 is equal to 4 e to the ln of 2 all over 2 t. Divide both sides by 4 to isolate e. And then we're going to take the natural log of both sides, just as we did before. And we get 16 is equal to e to the ln of 2 all over 2t. Take the natural log of both sides. I get the ln of 16. Natural log of 16 is equal to ln of 2 all over 2 by t. Rearranging, I get t is equal to 2 times the ln of 16. So there's a little bit of rearranging I'm glossing over here. I take it that you are confident to rearrange your equation slightly. All over the ln of 2. When I put this mess into the calculator, I get 8 out, and I know that t is in minutes. So we can see in these questions there isn't really any new maths. This is just applying the maths that we already know, being able to interpret the English like knowing that it initially or at the start is going to tell us that t is equal to 0. And other than that, it's very much just subbing into formulas and making rearrangements that we are already familiar with. So we're just going to build up some confidence with interpreting our English. And that's what we need for now.